You know, um, I'm chilling here and thinking like, I don't think I'll ever try to open a business which I can say it relates to some sort of manufacturing stuff, which I must use my hand to create now. I don't think I would like, I don't know, man. It would be cool to try it, but I can't think of any skill that I have where I can build stuff that I can actually impress people to sell that stuff. Now that brings me to my today's question. So our question for today, here is our question for today. So now that we've presented today's question, I can now open. Welcome to Simplified RSA. We are the guys who makes it looks easy. I'm Mr. Maimane, but also Simpiwe is one of my ID names. So yes, whenever I see a question like this with my name on it, I'm like, But now the question is this question about Simpiwe, which is me now in this case, if you look at it, or is it about my business of candles? Really? That's the question to ask. But hold that thought, right? Now, also, is this question about Mr. Man or not? So now, if you stay tuned until the end of the video, I'll answer first the mathematics question, which is mathematical literacy, by the way. So yeah, today we are doing mathematical literacy. Yeah, we are moving away Nyana, from the x and the y's of the equations. Mathematical literacy students, today is your day to shine. Yeah, man. So this question was extracted from a past question paper of mathematical literacy. But now, at the end of this video, we're going to find out if this question is it really about Simpiwe and his business candles. I believe you might have read the question by now. Or not all. Secondly, we're going to also answer, was this question really about Mr. Man or not? Now let's go. Okay, cool. So question 3.1 reads, Simpiwe makes candles as shown in the pictures below. He uses a cylindrical mold to make the candles. He also carves horse heads in some of the cylindrical candles, meaning like in some candles, like he carves some horse shape like horse to make it more like nicer, like the decoration, right? Something like that, because we can see as the image is showing on the image as well. So we have the candle mold. So it shows the shape of the candle and everything that is inside. And then the cylindrical candle, that's how the outcome of the candle is going to look like. So we have the width of the candle and also the height of the candle as shown 10.4 centimeters and 11.4 centimeters. That's the height of the candle. And then we have the picture of how the horse head candle kind of looks like. So it's like it's a cylindrical candle still, but it has like some extra decoration there in the form of a head. And then also we have that part at the bottom there. It shows a decorative ribbon around the candle. We'll see what does that mean. But now that's the information we have. Now again, I ask, is this question really about Simpiwe and the candles and the business candles? Or is this also about Mr. Man? But anyway, so so we're gonna use the picture above to answer the following questions. 3.1.1, Simpiwe will pack 12 cylindrical candles in a box using a 4 by 3 arrangement. They want us to determine the minimum length and width of the box he needs if candles are tightly packed together, like the candles are in touched, like they are so close. Like I think to understand the situation, I brought a small example here. You see, this candle, the way it is, this is the type of a situation we have. So for the first image, this is the outermost part. This is how you can imagine the candle mount. This is what makes this is what molds the, because this like it's plastic. So this could be the candle mount. So what is inside here? This now represents the part of the cylindrical cylinder. cylindrical candle. But then it's just what, like I said, this is a small example. In this case, we are looking at a bigger portion of this because we have the width, this part from here to here, according to the situation we have, is 10 centimeter. And then from here to here, that's when is our 11.4 centimeter. So small example, but then let's take it to the reality of the question for 3.1.1. So now we imagine those candles now. In a small example as it is now, imagine the box you have to put them inside. It has to be something like this, maybe. Let me make the box to be big just for the sake of the candles. Like you imagine a box like this, whereby now they're gonna be packed such that it's gonna be 3 this side by 4 this side. So it's gonna be 3 by 4. So 3, it's just that I'm not gonna be as accurate as I can, but now they are tightly closed. But you picture something like this 3 by 4. So 3 by 4. But now, if I take this such that we only see the top part, if I take this such that we only see the top part, therefore it's going to be like this accurately. If I take out the top part, uh, if I take out the top part for my 3 by 4 to be a bit accurate, so I have uh, this situation here. Something like this. So the candles inside the box, they should be like 3 by 4. But already, you know that one candle from here to here, now we are not looking at the height. Remember, these candles, they're like this from here to here. This is our 10.4 centimeter. From here to here, this is our 10.4 centimeter, like that. From here to here, this is our 10.4 centimeter. And from here to there, this is our 10.4 centimeter also. The only time we're going to talk about the height is when we're talking about from here to here. That's when we have 11.4 centimeter, which means now this part to this part, if it's 4 candles this side, it's going to be 4 times 10.4 centimeter. And also from here to here, it's gonna be 3 because it's 3 candles. It's gonna be 3 times 10.4 like that. It's 10.4 centimeters. Meaning, this is how I analyze the bigger picture. We haven't answered our question first. So now look, if this one also it's 10.4 from here, 10.4 from here, 10.4 from it means now this part, looking at it from above, from here to here, you have 3 times 10.4. And also from here up to there, because it's 4 candles, 1, 2, 3, 4, and which has the diameter of 10.4, 10.4, 10.4, 10.4. So now we're going to have 4 times the diameter of 4 times the diameter of each candle, I mean, slungu. So this is what we have. This is what we have in terms of the analysis of the package before we answer the question. So 3.1.1, we have to determine the minimum length and width of the box he will need usimpiwe if the candles are tidal packed and they are touching each other in the box, which is this situation here. So this side represents my length, this side can represent my width. I already have my calculations in line there. So for the width, I would say it's going to be 3 candles times the diameter of the candle, which is going to be 3 times 10.4 is 31.2 centimeters. And the length, I can just say L. And the length is going to be 4 times 10.4, which is then going to be 10.4 times 4. It's going to be 41.6 centimeters. So that's the answer for 3.1.1. And then this is how they're going to mark you. You're going to get your 2 marks for the width, and then you're going to get your 2 marks for the length, like that. That's how you answer 3.1.1. So now I ask again, is this question really about Simpiwe and the business candle, the business candle business? But also, is this question really about Mr. Man? Stay tuned. In the meantime, you can hit the subscribe button and press like and also follow us for more videos that relates to this. But otherwise, let's find out if this question is really about the business, and also let's find out if Mr. Man is really also. But let's go. So question 3.1.2 reads, Simpiwe then now ties a decorative ribbon around the candles. The ribbon has an overlap of 3 centimeters. Determine the number of candles he will be able to decorate with a 2 meter long ribbon. Now, SI units measures the most. I'll show you something important. With SI units, you must pay attention. Again, we are on mathematical literacy, meaning this is not a subject class, meaning this is not a physics subject related. We are on mathematical literacy. We are dealing with the candles here. So now you may use the following formula, and then from then we are given that the ribbon needed for 1 candle in centimeters is that. They say you may use the following formula. No, remove the may. Under mathematical literacy, every time they give you anything, let me make sure we hear each other on this one. Under mathematical literacy, every time they give you anything, you have to use it somehow. Each and every formula that is given, you will see as we do more questions related to this stuff, every information given is important, more especially the way it is given in the situation. It's even like, it's, okay, the word I'm looking for is bold. It's even bold, meaning it's some sort of an NP, some important something, something. So given that formula now, we're going to use it somehow, but we have to determine the number of candles. So now here's a situation. Again, here's a situation. Let me show you the small example. So now here is how we can picture the situation, right? From the candles, Simpiwe, he uses a ribbon to wrap the candles around something like this, nyana, so to decorate them. So as we see on the object below, the 3 objects there, they're even showing the decorative ribbon around the candle. Around the candle, it's just that this one is big. You see, like I don't have ribbons, but something. Imagine something like that. So now we have to calculate how long. Okay, no, they gave us the length of the ribbon. They gave us the length of the ribbon. So the length of the ribbon is 20 meters. It's 20 meters. That's our length of the ribbon. But now we have the formula. So, okay, now we are given the length of the ribbon, the total length of the ribbon, and the formula to calculate ribbon needed for 1 candle in centimeters. And then now we are required to calculate the number of candles that this ribbon can accommodate. We need to get the number of candles that can be wrapped around by this 20 meters, 20 meters ribbon, given that we know that the ribbon needed for 1 candle is this. Now, let's calculate the ribbon needed for 1 candle. We know that 1 candle has a diameter. We know that one candle has a diameter from here to here is 10.4 centimeters. And the height of the candle is 11, it's 11 point what? 11.4 also. Let me just quickly confirm. Yes, it's 11.4 centimeters. Now, the radius is always half the diameter. The radius is half the diameter. So the radius R, our radius will then gonna be, I can write it here. I would say our radius is gonna be 10.4 divided by 2, because radius is half the diameter. So therefore, our radius would be 5.20, or 5.2 rather, is fine, even if I can leave it like this, not to complicate it. So our radius is 5.2. So where there's a radius, I'll substitute 5.2. So meaning this then is going to be 2 times 3.142 times 5.2 for the radius, 5.2 plus 3 centimeter. If now you use a calculator to calculate this whole thing here, you just punch 2 times 1 point, no, you punch in 2 times 3.142 times 5.2, and you say plus 3 centimeter. Then you will get a total of, you will get a total of 35.6768 centimeters. This, this now represent, this represent the amount of, the amount of ribbon needed for one candle is 35.6768 centimeters, like this. 35.6768 centimeters, like this. Like I represent my points as dots because of, yeah, you'll understand some other time. But for now, we have the amount needed for one candle, the length needed for one candle, and we have the total length. Mara, another important thing not to fall for, one thing not to fall for, I say it again, SI units are important. So the length of the total, the total length of the ribbon is given in meters, but the formula for calculating the ribbon needed for one candle is given in centimeters. So first, before you do the punchline of the question, because we already know that we're going to take the total length of the ribbon and we divide it by the by the amount of by the length of the, how do I say this? By the amount of the length that is needed for one candle, the one we just calculated now. So if we divide the two, obviously we'll get our answer. But before you get to that, you must first line your SI unit. Either you convert the 35 centimeters into meters, or you convert the meters into centimeters. I settle with converting the meters into centimeters to make this more or less relatable, because our question came in centimeters anyway. So now we'll ask ourselves, how many centimeters are there in 20 meters? Conversion factor now. Still under mathematics literacy. So now you are being tested if you understand how to convert from centimeters to meters. Now let's go. So we'll ask ourselves, how many centimeters are there in 20 meters? I'm using conversion factor traditionally. How many centimeters are there in 20 meters? If I know that 100 centimeter, if I know that 100 centimeters is the same as 1 meter, how many centimeters are there in 20 meters if I know that 1 meter is the same as 100 centimeters? Obviously, I'm trying to manipulate the SI units. And from here, you can see that this meter will cancel this meter. And then I'm only left with centimeters. And then I'm going to multiply 20 times the centimeters that I have. Therefore, it means this is the same as 2000 centimeters. Now from here, I can calculate the number of candles that are needed. I mean, the number of candles that can be covered by a length of 200 centimeters. If I know that one candle can be covered by 35 centimeters, I just take this and divide that. Now let's get our final answer. So therefore, um, the number of candles that can be wrapped is gonna be the total length of the ribbon, which is 2,000 centimeters, over the ribbon needed for one candle. So that's gonna be 20 centimeters divided, 2,000 centimeters divided by 36768 centimeters. Therefore, our answer, it means we can cover up to, it means we can cover 56 candles. The ribbon can wrap 56 candles. That's what the answer mean. So that's it for 3.1.2. Okay, we are almost done. Now, 3.1.3, ne? The question reads, um, after carving a horseman in a cylindrical candle, Mr. Man Simpiwe, he collected the leftover wax, melted it, and poured it into a mold. The leftover melted wax filled a third of the mold, and then they want us to calculate the volume of wax needed for one horseman. So the volume of wax needed for one horseman is the leftover from the one third. Here's how we can do it. Number one, we have a formula again. They say you may use the following formula. You may not just think of, you might or might not. You have to use that formula. This is mathematical literacy, this one. We use that formula. Now let's use that formula first to calculate the full volume needed using the actual radius. Now we have more information about our cylinder. So we know that we know the radius is 5.2, and we know the height is 11.4. And we are given formula for the volume. They say now volume is equals to 3.142 times radius r squared times the height h. Ah man, by now you should know that this is how we summarize this formula anyway, because now I'm trying to save space. I can't write weight by weight. So here we'll then have our 3.142, which is our pi. Hey, never mind pi, man. It's not the pie we eat. 5.2 squared. Like sometimes people believe that students who are doing mathematical literacy, they don't know what a pi is. They know what a pi is. And if you don't know what a pi is, this is what a pi is. Pi is the same as that number, is 3.142, whatever. It goes, it's longer. But now let's not talk about pi. We're still here. But yeah, this formula was given. Um, our height is 11.4. Our height is 11.4. Therefore, this is, by the way, the full volume of the whole candle, the full volume of the whole candle, given that no complication, no any other thing. So there we get that the value, if you punch this on a calculator, remember there's a square here. To punch this on the calculator, there's a function where you punch this and you punch everything and like that. And our answer is then gonna be, our answer is then gonna be 968.54. Now, this is centimeters cubed. The SI unit for volume is centimeters cubed. And then now we want to know the volume of, because now here's the information. To get the volume of the leftover wax, the volume of the leftover wax, the volume of the leftover wax is going to be V1 over 3, the total volume. So So according to our question, the volume of the leftover wax is 1 over the original volume. So therefore, this is gonna be 1/3 times 968.54. And for this, we'll get that the answer is this will give us 3 322.847, something like this. So the volume of the leftover wax is this, and the total volume is this. This means that the volume of the host man is going to be this minus this. The volume to make the host mass, the host man is going to be this minus this because that is what is used. So the volume for the host man, to conclude our question, the volume for the host man, not host man, host head. I don't know why do I keep on saying host man. You'll forgive me as you watch this video throughout. Otherwise, please subscribe and follow for. Okay, so this is gonna be, and then it's gonna be the total volume, and then we subtract this. That's gonna be the volume that is needed to make a hot head. So that's gonna be 968.54 centimeters cubed minus 322.847 cubed. So therefore, there's gonna be 645.69 centimeters cubed. This is what is needed. Oh, by the way, here we were answering 1.1.3. We were answering 1.1.3, not 1.1.2. So this is now the conclusion of our question. If you have managed to watch this long, please don't forget to follow us, subscribe on our YouTube channel because we go live sometimes. Our learning channel is also available on Spotify. Follow us on all our social media platform, and don't be afraid or don't feel bad to send us a question you may have, any type of a question you may have under this email. The email is info@simplifiedrsa.com. Also, also feel free to contact us should you have any inquiries about our private lessons. Other than that, I'm Mr. Maimane. This is Simplified RSA, the guys who makes it looks easy, and my name is Simpiwe. Oh, before I conclude, I promise that I will tell is this question about Mr. Man or not. Well, in a bigger picture, it seems like this was a music subject. Because if you look at this question paper, it shows a longer vision of what it's rotating around the internet. With music subjects, I don't know how it works. Like, how do you study music even? But hey, hey, I don't know also if this music when we study is about art and how far can you respect someone's art. So I don't know how it works in the music department of education.